Okay, good afternoon, everyone. So today we are going to have suppose we are going to have a 1 hour lecture, but as I know, as you guys know, some of you have already done the tutorial 2 question, but we still have no chance to discuss about it. So today we use this 1 hour to discuss the answer. Okay, so hopefully everyone done everything. So, okay, let's start the discussion. So first question, calculate the intrinsic carrier concentration and I at 2 equals to 200, 400 and 600K for the silicon, germanium, and then gallium arsenide. So basically, you are going to calculate the Ni square, which is equals to the NCMV exponential negative Eg over Kt. And you know that the T is actually the changing. So basically, all the value will be changed. So I expect you guys already did everything here, especially the first question, which is relatively simple. So I would like to get someone to answer the first question A. First A. Ông Wei Hong. Okay. What's the answer of 1A? Ông Wei Hong, are you here? Yes. Your answer, please. 200K. Giga 5.827 times 10 to the power 6. 9, sorry. And then 400. Yes, Ông Wei Hong, are you still here? This one is for the 400, is it? Your answer is for which one? Okay, for the 200, your friend gave us an answer of the, let's see, 76.34 K. 3 per cm minus cube. Okay, so this is a 318 or 187 tera cm minus cube. Then what about the next one, 600K? Okay, 9.74 times 10 to the power 14 cm minus cube. The rest of you, are you able to get an answer? The rest of you? 同学问 what's your answer? And Brenda Koi, what's your answer? Brenda and Hong Xuewen, can you check whether your Ng Wei Hong answer is correct? Or do you get a different answer? And I, by right, you should square root it. Okay? After you get this, you should square root the Ni, square together Ni. Okay, let me check answer. I remember I got a record over here. Okay, so 7.26 2/38, 9.74, more or less. Okay, so I believe this is the correct answer. 7.3 tera. Okay, something like this. Okay, go to B. You are not supposed to get an Ni square. You are going to get the square root Ni square to get the Ni. Okay. So what about the germanium one? Lu Jiaming. What do you get for the germanium one? Are you here, Lu Jiaming? Yes. What's the answer for B? Answer for the germanium. Okay. All of you, please check the answer. 5.962, 1.432 times 10 to the power 10, and 2.4915 times 10 to the power 13. What about this? Do we have anything? You should have times something, right? Okay, yeah, correct. 5.96, 1.43 times 10 to the power 10, 2.49 times 10 to the power 13. Yep, all correct. Okay, let's go to the C. What's the answer for the C? Ng Han Xiang. What's the answer for C? Ng Han Xiang, you hear Ng Han Xiang? Don't see him here. Okay, you're here. So Ng Han Xiang give us the answer. 4.946 times 10 to the power 9, then 1.96 10 to the power 14, 8.778 times 10 to the power 15. Okay, for the rest of you, do you get the same answer for this? Lim Yong Chuan. Okay, thank you. Lim Yong Chuan, please stay back for a while after the class. I need to discuss something with you. Okay, Lim Yong Chuan. So let's proceed to the next question. Okay, given the effectiveness of the electron, hole and electron is calculate the position of the intrinsic Fermi energy level, EFI, minus limit gap, will be equals to 304 KT ln MP over Mn. Okay, so if you go back to the lecture 4, you can see the formula is over there. Okay, let's see lectures back. Lecture 4. By the way, can we have our midterm test by week 8? Is everyone okay with that? Means the week after next week. Is everyone okay with this? Supposedly we are going to have the week 6, but week 6 is this week. I don't think we can make it, so we make it by week 8. Is everyone okay? And your week 8, supposedly you don't have any submission, right? Okay, is everyone okay with this arrangement? So our weight 8 written test. Is everyone okay? I don't see it. Do you think it's okay the time? So if no objection, then I think I will put it as a weight 8. Everyone agree? Okay, so Sarah agrees since there's no response from you guys. So let's proceed to the discussion here today. So we are going to use this formula to do the question. So in order for us to do this, we need to know the MP and the MN. So the MN and the MP is already given in our slide. Okay, you can go back here. Okay, it's somewhere around here. MP, MN, this and this, this and this, this and this. So all you need to do is to replace the value inside there only. And then let's see. So this is in a 300K. So you know that this is 0.0259. Ron, then MP over MN. MP 0.56, MN 1.08. Okay, so what's the answer for this three? So we are going to deal with silicon, germanium, and the gallium arsenide. So let me pick someone to answer this. So Dan Xinsheng, can you tell me the answer? Dan Xinsheng, are you here? So you just tell me the value between the EFI minus E mid gap. What's the value for the silicon, germanium, gallium arsenide? These three. Okay, your friend give us the answer. So this is a 1.97.276 times 10 to the power v 2. Germanium negative 7.7 times 10 to the power negative 3. Then this is the 3.825 times 10 to the power negative 2. So the rest of you, do you get this answer? The rest of you? Okay, thank you. Okay, so let's proceed to the next question. So the next question also used by the same formula only, but somehow don't know where this there value. I think it's the answer, right, if not mistaken. Is it? So for the question 3A, okay, you also use the same value, 1/4 divided by 0.62, replace into the column inside there only. Okay, Huai Yihan, what's your answer for the 3A and 3B? Huai Yihan, are you here? Huai Yihan? Okay, 1.582, which is the answer in here. What about B? To get negative 0.0288. Okay, all right. So let's go to question 4. Okay, calculate the EFI with respect to the mid gap, center of the mid gap for the silicon, then center of the band gap for this one is the EFI minus the mid gap. Equals to, also use the same formula, KT ln MPOMN. Right now, just that the value is 200, 400, and 600. Okay, so let's see who can answer this. DOEC. Are you here, DOEC? Okay, can you tell me the answer for this tree? Question 4. A 0.5052 times 10 to the power 3. This is 0.0 negative 1701 negative 0.0255. Okay, for the rest of you, are you able to get this or this answer? Or you guys have a different one? What about you, Chen Xupian? Do you get the same value as your friend? Okay, looks like we have something different right now. Okay, the first one, you get the first one is 0.008492. 492. Okay, let's check who is the correct one. So let's see. So this one is an MPOM 056 1.08. Okay, math, math, math log 0.56 1.08. Okay, you get this. Then this thing has to be multiplied by 3 multiplied by k. K is 8.62 times 10 to the power of -5. And this thing multiplied by 100 divided by 4. 0.00849. I think this is the one given by the transcription. Okay, there you see, you make a mistake over there. Please take note. Okay, question 5. Oh, okay, typo. Determine the value of an annual MPO if the Fermi energy level is 0.22 above the valence band. EF, EB, EC. This is 0.22. What about this? We don't know, but we can get it from our table in the chapter 5, lecture 5. So you can open back lecture 5 to see the table inside the content there. Silicon, band gap energy. Band gap energy 1.12, this one. So you know that this thing total is 1.12. 1.12. So this is 1.12 minus 0.22. Okay? So the question asks you to calculate the NO and the PO. NO is equals to the NC. Then, what is it? The formula. Expression minus EC minus EF over KT. Since this is a 300K, So we know that the below one is 0.0259. So above one is negative 1.12 minus 0.22. And C. And C you can obtain from the table, which is 2.8 times 10 to the power 19. Okay, to verify this, you can go back to the slide, find what is NC, 2.8 times 10 to the power 19. Okay, and then PO will be the MV exponential EF minus EV over KT. Okay, so what is the answer for this low tier liệt? What's the answer? For the NO and the PO for question 5. Okay, thank you for the answer. And now will be equals to 2.269 times 10 to the power 4 cm minus cube PO 2.128 times 10 to the power 15 cm minus cube. Okay, are you guys getting the same answer? The remaining one, do you get the same answer as your friend? Or you get a different answer, you can type out. Okay, cool. Okay, let's proceed. The EC minus EF is equal to 0.225 at 400K. Calculate the annual and the PO. You may see that right now the T is equal to 400K, but it's not in the 300K. Okay, so NO equals to the NC ESP. So this is the EC minus EF 0.25 over KT. But right now the T is 400K. 0.0259 multiplied by 400 over 300. Your NC has to be changed also. Multiplied by 400 over 300, 3 over 2. Okay, this NC you can obtain from the table. NC, this is the gallium arsenide. So your NC should be 4.7 times 10 to the power 17. This is a 4.7 times 10 to the power 17. So same thing goes to the PO. Okay, you are going to write another PO. Lao Lục Tinh, what's the answer? Lao Lục Tinh, are you here, Lao Lục Tinh? Question 6A. Okay, 5.194 times 10 to the power 14. And O. What about PO? is definitely off. Why do you think so? Okay, for the NO, for the remaining of you, do you get the same answer? Okay, so it's 3, 5 times 10 to the power 15. Lim Yong Chan, what do you get for these two? You use the wrong formula. Okay. Uh, let's see the other guy. Lim Wen Yang, what about you? Do you get the same answer as the Lao Luk Jing? You get this and you get this. Lim Wen Yang, are you here, Lim Wen Yang? Lim Wen Yang, yes. Thank you for the reply. Where is the answer for the NO and the PO? For the question 6. 6A. Yes, have you done this question? For this question, you cannot find the answer. What's wrong with you guys? Why no one can do this? Ong Mei Ling, what about you? Okay, what's your answer? PO is 7.5. Okay, never mind. Let me calculate it right now. Since you guys are having so many funny answers. Okay, so we know that the EC minus EF is equal to 0.25. Gallium arsenide T equals to 400K. And then you also got K is 8.62 times 10 to the power negative 5. And then NC. Let's see what's NC. So according to your slide, gallium arsenide, your NC is 4.7 times 10 to the power 17. And V equals to 7 times 10 to the power 18. Okay, so let's try to calculate NO and PO. NO will be, this is a normal formula, math dot exponential minus DCF over 0.0259. This is the normal one. But right now it's in the 400K, so you no longer can use this formula. You need to do this. 400 over 300 over 5. And then I think also the same. Divide by 400 over 300. So this is the way you calculate the whole thing. So let me copy. So and also be 5 by something, 5/19 times 10 to the power of something. Okay, which is I think it's the correct one given by the Lao Lok Jing. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yeah, correct. PO also the same. Agree. Then this is the EFB. EFB will be equals to the Okay, let's see the band gap energy. The band gap energy is 1.42. 1.42 minus BCF. Okay, so you will get your PO 20819 by figure only. Okay, this is the way you do it. Yep, right looking. This one is correct. So very simple and easy. There's nothing to be worried about this thing. So let's proceed to the next question. Okay, assume that the value from the anode from the part A remain constant. Determine the EC minus EF and the PO at T equals to 300K. He's saying that if this thing is never change, okay, anode didn't change, but right now it's in the 300K. Determine the EC minus EF and the PO. Very simple. Assume they have a regular answer equals to this is the NC exponential minus EC minus EF over KT. Okay, so since this one is a 0.0259, because it's in the 300K, NC also the same, it will be the original value. Okay, which is a 4/7 times 10^17. So what is the answer for this? What is the answer for the EC minus EF? 0.084. Then what about PO? So your friend get 0.8804. What about PO? 10^15. The remaining of you, do you get the same answer as your friend? 0.804 and 10^15. Do you get the same answer, Aaron? Yong Minh Liang, what about you? Do you get the same answer as your friend, Yong Minh Liang? Are you here, Yong Minh Liang? Your yes means you get the same answer, is it? Okay, all right. So let's go to the question 7. Okay, the value of the PO at silicon 300K is 10^15. PO 10^15. So determine the EC minus EF, and then get the NO. 10^15. Then this is a silicon, NB exponential EF minus EV over 0.0259. So since this one is a silicon, this should be 1.08 times 10 to the power of 19. 1.04, 1.08, right? Let's see. Silicon, NB, 1.04. So by right, you should get the EF minus EV. Then after that, you use 1.12 minus this value. Then you will get the EC minus EF. So after that, you just need to replace into the value, then calculate the NO only. So let's see what is the answer about. You may know. What do you get the answer for this question? 7. Question 7. Both answer. 0.804, then 48.361. Who Hinh Dong, do you get the same answer as your Yong Ling Yang? Who Hinh Dong. Okay. All right, so let's proceed to the next question. Question 8. Okay. Consider silicon at T equals to 300K. Determine PO if EFI minus EF equals to 0.35. Okay, this one very simple. All you need is to go back to the lecture 4. Go back to the last slide. This thing, PO. Okay, so PO will be equals to Ni exponential EF minus EFI over 0.0259 if this is the 300K. If 400K, you need to use the other value. So let's see, it's 300K. Okay. So silicon, this thing, PO. So you can make an assumption here. Assume that this is the assumption of the Ni. Ni, you can use the value here. Ni, the value is somewhere given around here. Intrinsic carrier concentration 1.5 times 10 to the power 10. Exponential minus 0.35, 0.0259. Okay, then you are going to get the PO. So what's the value? Anyone get this value? Let me check. So Yan Chang, what about you? So Yan Chang, are you here? Yes, what's your answer for this question? Question A. Okay, your friend get 1.10 times 10 to the power 16 cm minus cube. The rest of you, do you get the same answer? Okay, cool. So assume the PO from the part A remain constant, determine the value of the EF at 5 and T equals to 500K. So basically, this one is a reverse engineering only. 1.10 times 10 to the power 16. So you assume the 1.5 times 10 to the power 10. You can change anything, but make the assumption here. Okay, wait. Let me see. Okay, so this is the EF minus EFI. So this thing right now, T is change to 400 times 8.62 times 10 to the power -5. Calculate what's the value here. Okay, so let me choose one guy. Long Yao Ting. Are you here, Long Yao Ting? Long Yao Ting. What's the answer for the B? Take B. Okay, you could be wrong for A. Never mind. Lisa Lim. What about you? Lisa Lim. Are you here, Lisa Lim? 0.466. The rest of you, do you get the same answer as Lisa Lim? Chicken. What about you? Okay. All right. So the NO and the PO, you just calculate accordingly. Because you already got a PO, you just need to use the NI square will be equals to NO multiplied PO. Okay. Yeah, I will temporarily skip egg and I first because 9 is the same thing. So I don't want to waste a lot of time there. Okay, let's see the question 10. Two semiconductor material have the same properties as the material A has band gap energy of 1 by E, 1 by EB, material B 1 by 2 EB, determine the ratio of the Ni to this and to that. Okay, he's saying that both are having the same material, just that the band gap energy is very different. ESP. So this is a -1 EV over 0.0259 if this is a 200K. Okay, this is Ni1, Ni2, and CME expression -1/2, 259. Okay, then you are going to get the ratio. Just divide it, and both NC and MB are the same. So eventually, your NIA Ni square A divided by Ni square B will be equals to the exponential -1 divided by exponential -1/2. Okay, then you square it to get the answer. So you can put the 0.0259 here, 0.0259 here, but I believe the answer is still the same. Okay, so let's see what's the answer. Okay, let me type here. Exponential given divided by 0.0259 divided by exponential by 2 divided by 0.0259. And then after that, you just need to square root it. By 5. So you get 47.51. Do you get the same answer as me? 47.51, the ratio. Okay, so next one. The Fermi energy for the copper at T equals to 300K is 7.0 eV. The electron in the copper follow the Fermi direct distribution. So find the probability of an energy level at T 7.15 being occupied by an electron. Okay. First thing we can know from the question is this thing is being occupied by an electron. So we can know that what formula to be used. 1 plus exponential E minus E F over KT. 1 divided by 1 plus exponential. So 7.15 minus 7, 0.5, 0.0259. Okay, so by having this, you are able to calculate the answer. So let's try this. One divided by 1 plus exponential. So this is the 0.15 divided 0.0259. Zero point 003. Okay, you should get 0.003. So you are going to get a 0.3%. So do you get the same answer as me? for this. Okay. So let's proceed to the next question. Repeat the part A for t equals to 1000 K. Assume the Fermi energy level is constant. Okay, so right now this one is the 1000 K. So this thing you have to change to 8.62 times 10 to the power 5 multiplied by 1000. So this is times 10 to the power 3. So you get 8.62 times 10 to the power negative 2. Okay, which will be equals to 0.0862. 2. That's 0.4. Means about 14%. So for the new one, you should get 0.14, which is about 14%. Okay, do you get the same answer as me? Okay. That is done. So question 3A, question C, I don't want to repeat it. It's still the same. So let's try this. Determine the probability that energy is empty for electron in the state below is the kT, 5 kT, 10 kT. Okay, so you can see that this is empty, so you are going to use this formula. 1 plus exponential E minus EF over kT. So this just change to the kT. Sorry, this should be the negative kT, negative 5 kT, and negative 10 kT. Okay? So what's the answer for this three? Okay, let me pick some guy to answer this. Theorem Ho. What's the answer for this? Question 12. ABC. Zero, 1, 3, 4. Next one. Okay, your friend gets 0.3734, 0.0933, and then 1. Do you guys get the same answer? Or canceling? Do you get the same answer? Okay, let me verify it. Okay, exactly the same. Okay, cool. So I don't have to do it. Question 13. If not mistaken, these three answers will be exactly as the same, these three answers, right? You can see that these three will be exactly the same answer for the 12 and the 13. Okay, so I don't have to explain it because this is the nature of the semiconductor. Okay, if you have one electron on the above one, then you should have one electron missing in the below. So this three will be the same as this three answer. Okay, so let's see. Apa ni ya? How come this one so weird one? Okay, if F equals to, this one should be easy. Wait, let me see. This thing a little bit weird. This thing should be easy and UV. Something typo here. Okay, let's check. So let me. Okay, if F equals to the EC should be find the probability of a being occupied at T equals to E should be the EC plus KT. This one should be minus EC. EF should be equal to EC. Okay, so this is the one. So your value should get about 0.7314. Okay, if I'm mistaken. And then the next one is EC equals to EV. This one is EV. Okay, one step below. So okay, let me recover this again. Easier. So this is 1. So this is 1 divided by 1 plus math dot exponential 1. 0.26. Okay, is 0.26. And then the next one. Find the probability of being still being empty at the EV minus KT if EF equals to EV. So this is you are going to use 1 plus exponential. So this is let's see, EV minus KT. Then this one is the minus EV. Okay, over KT. This thing become -1. So try to put inside the formula. So you use 1 minus 0.73. You should get the same answer, 0.27. Okay. So basically, both of the answer will be having the same answer, which is equal to 0.26 something, around 0.27. Okay, for the very last question. Okay, any questions so far? So finally, we'll go through everything for this tutorial 2, 90 tutorial 2. Okay, if no question, I think that's all for the class for today. Thank you very much for the attention, and I will see you by the next Monday. And the week after next week will be our test, midterm test. So good luck, everyone, and take good care. It really depends on the situation. If he asks you to find the NI, okay, then if the NI is given, then yes, you can use this formula. Okay. If he say that, okay, given the NI is equal to 1.5 times 10 to the power 10, then you are able to calculate in this way. Okay, I think that's all for today. Thank you very much. Lim Yong Chuan, stay back a while. Go Ken Sing got something to ask me. You also can stay back. Okay, bye everyone. Monday. Monday, no Friday. Okay, Lim Yong Chuan, I received your application for the entry, campus entry, right, Lim Yong Chuan?
Yeah, sir.
I have talked to your supervisor that it would be great if you only enter by the short semester instead of right now.
Oh, okay. So
you know, right now the pandemic is getting very, very serious right now.
yeah.
Want to avoid all this trouble.
Yeah, can. So only the short sem which will next sem, right? Is it?
The semester after the examination,
Okay. Okay. Can.
Okay.
Thank
So I
you.
think that's all. Thank you.
Okay.
Okay, Go Ken Sing, what's your problem? So the remaining of you can leave the classroom right now, no worry.
Sir, can I share the screen right now?
Yes, you can share.
Uh, can you see my screen?
Yes.
So I'm having the problem of the layout there when since the lab one, but it's okay. It's not affected uh the end of the part of the lab one, but the front of the part lab one I cannot construct the resistor here. Is it because my preference there I didn't set it up nicely?
Can you let me control a computer?
Yeah, sure.
I think you need to stop sharing first.
Okay.